I'm with Steve from MRX, which is a Siemens company. We're actually going to touch on one of my favorite topics, which is condition-based monitoring for both track infrastructure and rolling stock. However, Steve is going to be speaking to me about the broken rail detection system from MRX Siemens. I don't know if you can see my hand down here, this little baby, but I think what's particularly important or relevant for this piece of technology is that with theft and vandalism being such a problematic thing that our railway operators in Africa are experiencing, to take it off from the track side so it's not available to be stolen and actually put on the locomotive itself means that you actually get better information and data coming through, and it's safer all round. So, Steve, please tell me about this
device.
Yes, this device.
This is a very good device. It's a new device where it's mounted on either locomotive or a wagon.
Oh, so it can be both, locomotive or wagon.
It can be a locomotive or wagon. Mm-hmm. The advantage of this is that it detects the breaks in the rail and transmits information back to the back office, and the back office then informs control systems and control center that there is a break which has happened. And this is very useful because it is almost in real time.
So does it do the condition monitoring at the same time?
Right.
So for example, when the rail is broken, it's already a problem.
That's right.
So as it's on your locomotive or your wagon and it's going through, it's obviously picking up the condition of the track as it's going.
Now, for the time being, this device has been targeted to detect broken rail. However, there are sensors within this device which would be used in future to enhance reporting of the condition of the rail. There's accelerometers in here, yes, which would provide the vibration when the train passes through a section. And that is very important because normally on heavy trains, some of these breaks actually happen because of the impact of the rolling contact between
the wheel-rail
the wheel-rail interface, that huge forces are created which creates a break. And that is mainly true for heavy haul operations such as the iron ore, the Oryx line or the coal line. And that's why such a device, yes, currently it does not provide that information, but sensors within here have got that ability, and with the advent of artificial intelligence, this information is going to be critical. However, there is also additional information in here in that normally on the rail surface, yes, it's about 72 millimeters.
That's the profile head.
Yes, on the head. Mm-hmm. Now, we have got 13 sensors across that head, not only one sensor.
Okay.
So that means we've got multiple channels to check the condition of the rail.
Yes. Which,
as I said, in future, those additional channels will be used for informing the operators of the condition of the rail, not only the brakes. But that is in the future.
So this data is then sent to the control room, and that in itself allows quite a bit of opportunity for revenue saving at the same time, because then we're doing maintenance on track that needs it, as well as responding to broken rail as it happens, which minimizes disruption, because if something goes wrong, that costs money and stops operations.
Absolutely right. And now, the additional feature is here that you're not putting additional train or additional infrastructure to test the condition of the rail. You're using the revenue trains with this device to check your condition of the train. So you're pushing one train, which has got your ore body being taken to port, and at the same time it's doing your inspections. Okay. So that's one of the advantages. Whereas in some areas, they pass a special train called the inspection train. Yes. So the inspection train then passes. What that means is you have to now reduce. If the inspection train can, yes, you have to reduce the number of trains passing because you have to accommodate this additional train on the network.
And there's scope for this to then grow into feeding into this whole, digitalisation and the strategy around the Internet of Things for rail.
Yes. Now, as an example, this device you can fit onto a number of trains which are operating on the network. That data which is being collected can now go to the big data sort of analysis entity for analysis to be able to give you a good information of projections. What is actually happening? How many breaks you're getting? And are they actually happening under a train or are they happening due to condition of weather? Okay, so if the break has been detected under the train, then some of these are happening because of axle load. But also it could be happening because of your maintenance of the rails.
Yes.
So that is one of the advantages of this device.
Okay.
Now, when you talk about the big data stuff, Siemens has a database system which we call Religent.
Yes.
Now, Religent is one of these things which you could pick data from multiple sources, okay?
Yes.
From rolling stock, from wayside devices, from other devices, to aggregate so that you get what we call maintenance intelligence.
Yes.
And that maintenance intelligence is where everybody will be heading to get the benefit of the data available across all these devices.
Yes. Okay, well, Steve, thank you very much. And I'm sure I'll see more of this in Germany soon.
You will. If you're going to InnoTrans, you'll be welcome to our booth and you'll see one of these devices in there.
All right, so what we're going to do is, I'm sure you've got a brochure for this. We'll link it below in the description and you can access it and then contact the Siemens team for more information.